And now, let's explore repair. Over time, nodes can get out of sync due to network troubles, nodes failing, corrupted disks, and so on. When querying your Apache Cassandra database, you have to decide between consistency versus availability during a network partition. This goes back to the CAP theorem. With Apache Cassandra, you can tune whether nodes are always in sync with each other versus being highly available. When there's a network partition, do you want to force your clients to wait until the system is in a consistent state? Or do you want to give clients the best answer available? Choosing availability means there could be a disagreement between replicas as to the actual data value during a network partition. Let's examine in detail what generally happens on a read with a full consistency level. Here's our cluster with data. A request comes into the cluster. The left node acts as the coordinator. This request has a consistency level of all, which is the highest consistency level that you can require. These three nodes store the replicas of interest. The coordinator forwards the request to all three nodes. In this case, the most responsive node is the one on the bottom, so the coordinator asks it for the actual data. The coordinator only requires a digest or checksum of the data, not the actual data from the other replica nodes. This is an optimization. The bottom node returns the replica. The other nodes return their checksum values. The coordinator executes the checksum on the data returned by the bottom node and compares all of the checksums to determine whether they match. The coordinator returns the data to the client. Now, let's consider a similar scenario where the checksums don't match. Again, a request comes into the cluster with the left node acting as the coordinator. The consistency level is all, meaning the coordinator must verify all replicas are in sync. The coordinator forwards the request to all the nodes. Notice the checksums don't match. Something's out of sync. The bottom node returns the data. The other nodes return checksums. The coordinator performs a checksum on the replica and again compares all the checksums, noting that something's awry. The coordinator is responsible for syncing all the nodes with the latest data. Recall that each cell of data stores a timestamp. The coordinator can use this timestamp to determine which replica has the latest data. In this case, the replica returned by the bottom node has a timestamp of 135. The coordinator requests the full replicas from the other two nodes. Notice the right node has the latest timestamp, which is 159. The two replica nodes return their copies. The coordinator discards the other replicas. The coordinator sends copies of the latest replica to the nodes that are out of date, while simultaneously returning the result to the client. Obviously, executing queries with a consistency level of all trades time for having correct results 100% of the time. Depending on your situation, you may find you require less consistency where only most of the time you will get the correct result. In cases where you query for a consistency level less than all, Apache Cassandra will still perform a read repair probabilistically. This probability is configurable, but it defaults to 10% of the time with DC local read repair chance. However, when Apache Cassandra performs a read repair under these circumstances, it does so asynchronously. That is, the client may receive stale data, but Apache Cassandra synchronizes the data immediately after for any further requests on that particular result set. You can use Node Tool to run a full repair. However, a full repair can quickly bog down your entire cluster depending on the amount of data you need to repair. Look at this as the last line of defense. If you have a node that's down for a long time, you may need to repair that node. Nodes that aren't read from may also benefit from a refresh now and then. Now, why don't you try repair with this exercise?